Let's do the boilerplate basic game of how to use some double angles, and then we'll play the same game with half angles. So we'll start off, know your sine, know your cosine, double angles. Just more about to handle a problem like this. Your text loves you for some reason. I don't know what it is, so I wrote mine in you. Say you don't like it. You're like, I don't like that. I like this. Make little thetas. Maybe you're getting used to theta now? You got that muscle memory? Because I know I sure as hell do. In math, we're allowed to do that. Don't do that in physics, though. Don't change variables. Your teacher will get super pissed at you. So we're gonna want to go find it. So what the game is, you get a trig function, and it tells you what quadrant you're in. And then we want to know what sine of double angle is, cosine double angle, and tangent double angle. Things we don't know what the angle is. Well, we could totally find out what the angle is. We totally could find out what the angle is. I can tell you. Nah, I just let you look at it. Okay. There's a bunch of them. It's infinitely many. This is our game. Make a frickin' triangle. All whole numbers are over 1. Usually you'll see sine is equal to 3 over 5 or something like that. But it's telling us, make a frickin' triangle and make it in the fourth quadrant. Well, wait a second. Secant of theta is equal to 2 over 1? Yeah, you can go kick rocks with that. I'm going to deal with cosine and just flip over the ratio. Oh. That look familiar to you at all? You know what I mean? Cosine of theta equals a half. Well, let's find out. 1, and that's going to be the 2. I wonder what this number could possibly be down here. Could it be root 3? That triangle? But it's going to be also negative down here. So we just described our triangle. We just described, well, theta is actually going around this way, but we look at the reference angle inside of our triangle. And now we want to know what sine of theta. Sine of theta is going to be that negative root 3 over 2. Cosine of theta, we already know it. Cosine of theta was equal to a half. Dude, I think we can solve. I think we can go and get this. Huh? Sine's double angle is 2 times sine of theta cosine of theta. So what's that? Negative root 3 over 2 for our sine. We're going to get 1/2 for our cosine. I think those two 2's go away, and we're going to end up with, what's that? Negative root 3 over 2. Oh, wow. Oh, wow. Neat. Neat. And now let's deal with our cosine function. Now which one do you want to use? It's up to you. You got 3 different formulas. Typically, if I'm not doing an identity, I use the same one each and every time. Cosine squared minus sine squared. Not cosine squared plus sine squared. But a minus, sorry. Just give me the answer for number 1. So let's just pop it in. We've already done the hard work. The hard work's making the frickin' triangle. Are you saying that when in doubt, maybe make a frickin' triangle and see what the heck's up? That might be helpful. Actually, when doing these problems, the cosine squared plus minus sine squared is actually much easier to do. So you're going to get 1 minus 4 over minus. This one's going to turn positive. You get 3 over 4. So that's negative 2 over 4 or negative 1/2. Oh, weird. Oh, weird. When sine was a root 3 over 2, cosine was a 1/2. Strange. That is some wacky shit, you know what I mean? And then tangent of 2 theta, well, we already know that answer. That's just sine of a cosine. That's just sine of 2 theta over cosine of 2 theta. That's just negative root 3 over 2 over negative 1/2. So those 2's just go away. The negatives cancel out. So we just get positive root 3 over 1. So tangent of 2 theta is equal to root 3. What quadrant did that double angle end up in? Where sine's negative, cosine's negative, and tangent is positive. I think when we spun this angle around again, it went and ended up over here. That's a double angle. So it can go twice as far. We could use just the angle to go find it out. All right. There's a game. There's a game. Now let's do this one. Let's play the same thing. we're going to say that secant of theta is equal to positive 2. We're going to stay in the same freaking quadrant. We're going to do all the same stuff. We're like, this is good. We know we got ourselves a little triangle down here in the fourth quadrant. We got our, what was that? Root 3 negative. We had our 1, and then we have our 2 right there. We found out that sine of this angle was negative root 3 over 2, and we knew that cosine of that angle was equal to 1/2. Beautiful. But now we want to ask games maybe like this. What's sine of theta divided by 2? What's the half angle of these? And I'm not even going to go with tangent on this one. Just do these two. And we have formulas for them. So if we were wanting to do like a couple more, find out just our half angles, because our theta is here. We ended up in the fourth quadrant. So we're going to go find out where half, like we're halfway. I don't know, what about halfway look like there? Would that be about halfway around to it? I don't know, maybe a little further? Half the angle? The angle's 5 pi over 3. You can cut that shit in half and find out what the answer is. But, okay. Well, our formula is that sine is equal to plus or minus the square root of 1 minus cosine of theta over 2. And this one's equal to plus or minus 1 plus cosine of theta over 2. Using our same information from above. Well, we could just pop this in. We actually don't really give two shits about the sine value, because when we go to find our sine half angles and cosine half angles, the only thing inside is actually just cosine of theta. And we know cosine of theta, it's equal to 1/2. And it's not always going to be nice numbers like this. A lot of times you're going to get wacky stuff. You will definitely find out in your homework. So sine of theta over 2. I'm going to leave that plus or minus out there. Now when you take your test, leaving a plus or a minus is just like just choosing the wrong sign. I'll always mark you wrong. You have to choose in a second as to which one it is. So 1 minus over 2, and cosine of theta was equal to 1/2. This is also going to tell us that cosine of theta over 2 is just going to equal plus or minus the square root of 1 plus 1/2 over 2. Well, let's clean them up. 1 minus 1/2 up top, that's just going to be 1/2. And what's 1/2 of 1/2? What's 1/2 of 1/2? 1/4. So we get plus or minus 1 over the square root of 2, or plus or minus the square root of 2 over 2. Huh? I totally accept the 1 over root 2. I don't mind about that. But now we need to choose. Is this positive or negative? Which one is it? Well, if we want to know half an angle, why don't we take where the angle is and cut it in half, and let's take a look. Look back up top. They said we were between 3 pi over 2 and 2 pi. Cut it in half. That makes it 3 pi over 4. Oh, let me cut the angle in half there too. To pi. So it's saying if you're ever in the fourth quadrant, you take half that angle, you're going to end up in the second quadrant. Now, is sine positive or negative up in the second quadrant? It's freaking positive. Hence, we're going to take the positive of this answer. And that tells us that we're going to play the same game. We have the same angle in that second quadrant, so cosines is going to be negative. Whatever answer we get, we're going to make it negative. So we get the negative square root of, that's going to be 3/2 over 2. Sorry, I'm jumping the steps. I'm assuming you know how to do arithmetic. I know it's tricky, and I am jumping a lot of steps. It's hard to follow, but you do the steps to follow, to catch up and do your homework. Sorry for babbling. So we end up with these two values. We nailed it. We got it. We kicked its butt. Oh, shoot. My answer's wrong on the left. I see it. Woo! The square root of 4 is freaking 2. I knew something was wrong. So we're going to take this as 1/2. Okay. Wait. If one of our answers is negative root 3 over 2, the other one has to be 1/2. So, whoo, I got it. And there's your sine of the half angle. You got your cosine of your half angle. And yeah, that's one of the games. So the last thing we'll probably do, maybe do an identity, maybe do a little other. Oh, no, I know what it is. Reduction formula. You're going to love this one. See you then.